Some years ago, there was a famous advertising campaign of an Italian company whose claim was, "Power is nothing without control." Well, the same applies to post-production workflows, because using the most advanced techniques and tools can lead to terrible results if you don't have the possibility of checking what you're doing, to check when it's too much or when it's not enough. And this is why we have a utility section inside the Mindthecolor extension. Thanks to Carlo Diamanti, we now have available inside Photoshop some instruments for checking the color and luminosity that we were missing for so many years. I'm talking about the Vectorscope, for example, that thanks to its circular representation can help us to evaluate hue and saturation when we are using the color wheels, or the Waveform and the parade that can tell us how and where is allocated the tonal range inside of an image, or the tonal map, or the false color that we have already seen in action in a few videos. Now, let's take a look at this very important section of the Mindthecolor extension. When I click on the Utility button, the first tool that shows up is the Vectorscope. Now, to understand how the Vectorscope works, we need to talk about the RGB color mode. We know that in RGB, an image is made by three primary colors, red, green, and blue, that mixed together can give us different colors. Also, we must consider that this applies not only when we have the maximum value of each color, but also when we have a value that can change from the minimum, that is 0, to the maximum, that is 255, for example, in an 8-bit RGB file. For example, we can have many shades of red, from the black to the maximum intensity of red. And the same is true for the green, from black to the maximum green, and also for the blue, from black to the maximum value of the blue. And as we have said before, we know that when two of them are mixed together, we have, for example, yellow when we have red and green mixed together. We have magenta when we have red and blue mixed together. And we have a cyan when we have a green and blue mixed together. And when all of them are mixed together, we have white. This representation made only by circles shows up only the maximum value of each primary and secondary color, but of course we can have many shades of the secondary colors as well. For example, so we have green and blue together, we have all the shades of cyan, red and blue together, we have all the shades of magenta, and red and green together, we have all the shades of yellow. And when we have all the RGB mixed equally together, we have all the shades of white, or better, all the shades of gray from black to white. So far, we have seen only two graphic representations of the RGB colors. Of course, we can have more of them, but for now, let's keep in mind that with the bars we can see the brightness of each color, and with the circles we can see the hue of each color. Now, one interesting thing about the circular representation is that we can expand it. For example, we can add a radius for each primary color, but also for each secondary color, and for any color that falls between a primary and a secondary color. With this option, I can see where is located a color made by equal parts of red and blue, that is the magenta radius, but also where is located a color made by more red than blue, that is a kind of cold red, or by more red than green, that is an orange, and so on. If we connect all the radii together with a circle, we can express all the possible hues with an angle, from red to green to blue, and so on back to the red. In other words, with this representation, we can create a circle based on the hue that can be considered as a color map in which every hue has an angle. Further, this can be useful also for the saturation of every color. We can, for example, define the saturation depending on how far from the center a certain color is located. And we can apply this model to all the main tonal ranges like shadows, midtones, and highlights. As you can imagine, This is the exact idea behind the color wheels command that are available with the same tonal ranges, shadows, midtone and highlights, but it's also very close to the Vectorscope, where we have the hue circle and also a reference for each color, red, green and blue and cyan, magenta and yellow. The angles are not exactly the same of our graphic layout, but the concept remains. Looking at the Vectorscope, it's very easy to understand the colors we are looking at. In this Vectorscope, we have the signal of the image on the right. In this area, for example, I have warm colors, and I see also that we have a kind of a neutral warm colors because I have something around the center. We are looking at the skin tone, the almost gray background and the yellow lights of this image. Here instead I have some red, that is the girl's red shirt, and I see that it is more saturated than the other colors because the distance of this color from the center is bigger than the others. And also I see that is a kind of cold red because the hue is not exactly on the red reference, but is slightly shifted towards the magenta. When we have neutral or desaturated colors, the signal will be around the center. And last thing, we have also a reference for the skin tones. That is this line called the skin tone indicator. And you can see that the skin tones of this image can be considered correct because are in line to the skin tone indicator line. Of course, this line must not be taken as an absolute reference, but can help you to check if a skin tone is more or less correct or has any cast. Now I think you can see how useful can be a tool like this. And thanks to Carlo Diamanti, we have now the Vectorscope inside Photoshop through the Mindthecolor extension. For example, if I click on the Vector button, you can see that I have the signal perfectly aligned to every reference, red, green, blue, and also yellow, cyan, and magenta. And if I turn on this rainbow gradient that goes from the red through the yellow, green, cyan, blue, and so on, back to the red, and I click on the Vector button again, now this rainbow gradient is represented by the circle going from the red reference through the yellow, green, cyan, blue, magenta, and back to the red. And when I start to desaturate the image, I'm gonna do this with a hue saturation layer. I'm gonna lower the saturation by maybe 20 points or so. And I'm gonna press the Vector button again. You can see that the hue circle becomes smaller. And this means that now I have less saturated colors. And I can go further and click on the Vector button. And you can see the more I lower the saturation, the smaller the circle becomes. If, for example, I desaturate the cyan like this, and then I click on the Vector button, you can see how the signal appears now in the Vectorscope. Now, if I do the same for another color, let's say the magentas by 30 points, and I click on the Vector button again, you can see how the signal is changing in the Vectorscope. And when I go to the master command and I change the hue, for example, like this, you can see how the hues are rotated in the Vectorscope. And we have now all the reds shifted towards the magenta, as we can see here. And I can go on the other side and shift the reds towards the green or the yellow. And you can see here, now here are our reds, and so on. So I'm going to reset this. And if I bring down the saturation, something like this, for example, or even more down to the 0, now you see that I have only a small point in the center because there is no hue and saturation to show. Now I think you understand the real power of this tool. In combination with the color wheels, for example, we can very easily correct colors by moving any cursor of the shadows, the midtones, or the highlights in the right direction, and check at the same time in the Vectorscope what we are doing and stop when we are done. Well, so far so good with the hue saturation and Vectorscope. It's time to talk about something that can help us with the tonal range, the waveform and the parade. Basically, what the waveform does is to tell us luminosity values. Of course, we already have something similar inside Photoshop, that is the histogram, but the waveform is more helpful because it can tell us where a certain luminosity value is located on the width of our image. Here I can click on the W button, and now you see I have the wave button. I'm going to turn off the hue saturation layer and also the RGB wheels. And now I can click on the wave button. And this is the signal I'm looking at. Now, starting from the left, you can see that the waveform is showing all the luminosity values of this red gradient, and it's the same red gradient here. But you can see also that in the waveform, the signal appears in the same position of the image, because this red gradient is located on the left. And going to the right, you can see that the same happens for all the color gradients. So we have also the luminosity values of the green gradient, the blue, the cyan, the magenta, and the yellow. And you can see that the representation here in the waveform is the same as we have on the width of our image. Now, if I desaturate all the colors with this layer, I'm going to put this in color mode, and then I click again on the wave button. Now you can see that the signal has changed because the lightness has changed, but the gradient's position remains the same. And if I turn on this horizontal gradient and I click again on the wave button, now I have a sort of line going from the left, and we have the darkest value here, to the lightest one that is on the right. Another tool I want to show you is strictly connected to the waveform, and is the parade. Basically, it's like having three different waveforms, one for the red, one for the green, and one for the blue. The kind of signal we have in the parade is exactly the same of the waveform, but we have three separate signals, so we can check which kind of lightness we have in every RGB channel. For showing the parade, I'm gonna turn off this layer. I'm going to click on the P button, and now I can click on the parade button, and you see now that it's like having three separate waveforms, one besides each other. And the graphic representation reflects where certain colors are located on the width of my image. So you can see, for example, that we have a slightly different position of every gradient in the red, green, and blue channel, because they are made by different RGB color values. Now, if I turn on again this hue saturation layer and then I click on the parade button again, we will see that now the three waveforms are exactly the same, because we have neutral colors, and when we have neutral colors in RGB, they have the same luminosity values in the three channels. All these three utilities, or better instruments, the Vectorscope, the Waveform, and the Parade, make much easier matching color and luminosity in different images. In images like this, for example, we can start to match first the tonal range. So I can click on the Waveform button, and I'm going to check the waveform of the image on the right. Okay, and then I can check the image on the left. As you can see, the left image signal has a lot of information in the bright tones, much more than the right one. So it's clear that I must first match the tonal range. And also I see that the black level is a little bit higher than the right image. So I'm going to move on the right image. I'm going to click on the wave button. And I can start to use a curves layer, where I can do something like this. For example, I'm going to raise a little bit the black and click again the waveform. Yeah, more or less we have the same signal. Let me check back on the left image. Yes, more or less we have the same level. Then I switch back on the right image, and I can move, for example, the lights a little bit higher. Let me check now. Okay, and then I can darken the shadows a little bit, like this. Okay, I think we are getting closer. And now that the tonal range is good enough, I can switch to the colors and I can use the Vectorscope for this. So I'm going to click on the V button and check the Vectorscope of the left image. Now, if I check the colors, I can see that the left image has mostly warm colors as the signal is located in this area between the yellow and red. Now, when I click on the right image and check the Vectorscope, and I can see a different signal. This means that this image is featuring some cold colors here that must shift towards the warm colors. And that's the perfect job for the color wheels. So I'm going to click on the color wheels and maybe I can start from the midtones and then the shadow and maybe also the highlights. Here, remember, we have many options, so I can try, for example, the curves first. Okay. So let's see, we need to move everything towards the warm colors. Okay. I think we are getting closer. Let's check again with the Vectorscope. And you can see here that we have less cold colors, so I can keep going. I'm gonna click back on the wheels. I can do the same in the highlights, for example. Oh, maybe this is too much. Maybe I can go back in the midtones and do something on the opposite way in the shadows. Now, as you can see, I have two Mindthecolor curves because I have clicked on the utility button and then I have chosen the wheel again. So the panel understands that I want to do an additional move. Let me check if all these two curves can work together. Now, that's the first curve. I would say not too bad. And that's the second curve. Maybe the second one is better, or I can keep both of them. Maybe just a little bit less of this one. Now I'm going to check again with the Vectorscope what I have. And you can see here that now I have a signal that is very similar to the one of the left. Okay, maybe here we don't have a kind of red color, so I'm going to switch back on the right image. Click again on the Vectorscope, and maybe I can add a hue saturation layer. And for example, I can go into the reds and maybe shift the hue of the reds just a little bit towards the yellow. Not too much, I would say. And also maybe the yellows just a little bit towards the red. And lower some saturation. Like this. Okay, now let's check the signal in the Vectorscope. Okay, not a perfect match, but remember, we started from here and we are here. Not exactly perfect yet, because we have different kind of images, tonal ranges and colors. Maybe on the right image we will need some additional local moves in the highlights, but anyway, you can see now how in a matter of minutes three simple tools like the Vectorscope, the Waveform and the color wheels can help us for color matching. That is one of the most difficult tasks to do without any proper tool. Also, when we talk about color matching, we always need some image analysis for checking the differences between the original and the reference image. But doing this kind of analysis without any help means spending much more time in guessing which move is the right one for our image and also how far we have to go. And finally, we must remember that this kind of tools were not available inside Photoshop until Carlo Diamanti added them inside the Mindthecolor extension. Now, let's see another case. Let's say this time I want to match the left image to the right one. Again, I must check both colors and tonal range, so I'm gonna click on the Vectorscope on the left image, and we already know that we have the warm colors, because we have this kind of colors located into the Vectorscope. Now let's check on the right image. And as expected, I have reds, gold colors, very different from the left ones. But I think the problem here is also the tonal range. If I check the waveform, for example, I'm going to click here and check the waveform. You can see that this is what we have. Now, compared to the left, I'm going to check the left tonal range, and the allocation is different. And if I have to match the two tonal ranges beyond the help of the waveform, the best help can come from another great tool available here in the retouch area, that is the false color. Now, false color is pretty unknown in the retouching field, but in the video field is one of the most common tools, is the most used tool for checking the exposure on the set and also for checking different cameras when we are exposing a scene. And now, thanks to Carlo Diamanti, we have the false color available inside the retouch area. And here, when I click on this button, false color creates a tonal range map and a color palette in which every color is related to a specific brightness value of the image. So we have purple for almost pure black, blue and cyan for deep shadows, dark grays for lighter shadows, green for the midtones, pinks and light grays for the bright tones, and yellow and orange for the highlights, and red for almost pure white. Now, with this kind of map, it's very easy to evaluate the tonal range of the two images. So I'm going to use the false color on the second image. I'm going to click on the false color button here and see how different are the two tonal ranges. Now, even if the waveform told me that the two images were not so far from each other, I clearly see where are the differences. So I'm going to switch back on the left image. And here I can use a curves adjustment layer. So I'm going to first darken the black point. I see some kind of blue. Okay, something like this. And then I can raise the midpoint of the curve until I see yellow and orange in the girl's face, like this. Okay, so let's turn off the false color in both images and check the result. So this is my start image, and this is my reference. Now that I have a similar tonal range allocation, I can do something with the color. So I'm going to go back on the left image and I'm going to switch on the utility and choose the Vectorscope for this and check the colors for both images. And now on the right image. Okay. Now, thanks to the Vectorscope, I have an idea of what I need to do in the color wheels. So I'm going to click on the wheels and I can choose an option for this. Maybe curves are too aggressive. I'm going to start with something soft like gradient Versa. I will start from the midtones and push them towards the cold colors. And when I do this, I immediately see that we are getting close. Okay, not too bad, I would say. And I can do something also in the highlights and lower them just a little bit. And push them towards the coldness. Okay, let's try something more aggressive here. And maybe I can do something in the shadows as well. Oh, much better, I would say. Maybe I need some cold colors in the background, so I can make a rough selection of this area. And try to do something with the curves layer, for example, to add more cyan. Maybe not so much. And some blue as well. Okay, so I'm gonna blur the mask here with a large feather. Maybe I can also paint on this mask here with the white 50%. And I can also paint here for adding some coldness. And that's before and that's after. Now let's check the signal we have in the Vectorscope in this image. Okay, so I can go further with the curve here. Okay, much better. And more blue. Okay, of course I need to refine the mask here. So I'm gonna paint back with this. And also here, behind the head. And also here and here. Just a little bit. Let's check the Vectorscope again. And now I see that I have more cold colors like we have in the right image. Maybe I can try to add some saturation or vibrance. So for example, I'm going to try first the vibrance. Okay, now the saturation is okay. So I can leave this too. And that's before and that's after. A very subtle move. And let's check the before and after. Of course, for a perfect match, I'm missing some colors in my image, like, for example, the red of the sweater and the cyan of the hat. So, unless we want to paint with the red in the sweater and with the cyan in the hat, I would say that this is a good color match. Remember, we started from this, and now we are at this point. And, as usual, the question is always the same. How much can we match the two images? But there is also another question, that is, how far are the two images? How far are the colors and the luminosity, the tonal range of the two images? Now you can really understand that without this kind of tools, without this kind of instruments, color matching is going to be rather difficult, because I don't have any instruments that can tell me which direction I have to take with the color wheels. And therefore, it's going to be a matter of spending much more time in guessing the kind of move I have to do. And now there is one last tool I need to show you, that is the tonal map. This tool creates a map in which all the kind of colors available in the image are represented with the maximum saturation. Now, let me click on this button here. And on an image like this, if I lower the map opacity, I can see where these colors are located, of course. Now the question can be, what is this for? Well, this can be useful, for example, in images where we have a very low saturated colors like this one, you can see here. And we want to see what kind of colors we have without running the Vectorscope, but also we want to check where these kind of colors are located inside our image. Or, for example, when we have to check if we have a mild color cast in certain areas. So I'm going to switch on this image and I'm going to run the tonal map here. And so when I lower the opacity of the tonal map layer, you can see here that I have a clear indication of the kind of color cast I have in the background. So I can see now that In the background, I have very cool colors, and also, of course, in the dress, because I see that. But here, colors that look almost neutral, actually they're not. And you can see this from the tonal map. So again, a little help for color matching and color manipulation. Okay, as you have seen, the Mindthecolor extension is an amazing collection of professional tools for color manipulation and retouching, but also it's a collection of instruments for keeping everything under control. All this together can really bring your skills to a new level, expanding your workflow and at the same time making it faster and more flexible. Thanks to Carlo Diamanti, we have now available in Photoshop tools like the color wheels that are the perfect companion of the Vectorscope. We have the Waveform and the false color that, used in combination with other tools like the CurveM, can really boost your productivity. And don't forget about the other sections like retouch that can really expand your retouching skills, or Ctrl D and Ctrl CM that can really change the way you look at images. With all this power available, now I think you can understand why I said power is nothing without control at the beginning of this video.